So once more time, my name is Mariusz Czachowski. I will provide today's session about the BlueSpark Residential ESS solution for the households and for the households, for the single use and the parallel use. I'm responsible for the CE technical support. And also we have a local engineers in many countries in this region. Also, we are focused in the Baltic countries as Lithuania, Latvia, and Estonia, where we already has our energy storage solutions implemented in the residential and also in commercial. Regarding the system, what is the highlight of the KSTAR energy storage system? First of all, is a solution all-in-one for solar storage and smart home integration, like a heat pump, like a diesel generator. Also, we are optimized for the dynamic tariffs and VPP participation. It's including cooperation with the third-party EMS providers, which helps us to meet the client's requirement. The new generation, because it's the second generation of our inverters and our batteries, is a cableless and wireless design for very easy installation. Very easy and fast installation allows us to do it. Also for the distribution channels, it's very easy to supply for the end customers because we don't provide the cables. We are only providing the inverters and the batteries, however, how many you want, and then we are connecting in by the wireless connection. The system is modular, scalable, and flexible for our needs. So that means we can use for the battery-ready design as only inverter with the PV modules. Also, we can connect one battery and then decide to connect two of them, or 3, 4, 5, and 6, because our solution is low voltage, so we don't have to adjust the voltage during the connection next batteries. Everything you need to do is to levelize them by charging it up to 100%. Of course, at the beginning, I would like to say that all the questions are welcome, and this webinar is for you, so I will be pleased to answer all of your questions. Many technicals, but from the commercial side, we have also Lisa, which is responsible for this market. The first, I would like to show you the short movie. Unfortunately, without the voice. Let's say we have some kind of technical problem. But as you can see, the system is stackable. We have 3-phase and single-phase inverters. All of the models can be changed, can be added accordingly to our needs. We implemented in the AFCA technology. Many of installers, many of customers is asking for it. So it's an optional version. So if you need that kind of thing, let's ask us if the product number contains this kind of feature. We implemented many typical working mode like self-consumption, battery priority, peak shaving. We can work in a single line or also in a parallel line connection. And our monitoring is currently based on the SolarMan, but we also are developing the new platform, which will be only KSTAR fully developed platform. And in this platform, we will introduce the dynamic tariffs as well. What are the highlights? What is the system and what the system is providing us? First of all, we have first 1-phase and 3-phase inverters. For the single phase, it's 3.68, 5 and 6 kilowatts. For the 3-phase, we have from 4 up to 12 kilowatts of the inverters. We are using the Tier 1 premium cell battery banks. I will mention about it later. And what I mentioned already, it's swappable and expandable. So let's say comparing to the competitors with the high voltage solutions, with no module level optimization. If there will be one module faulty or they will get disbalanced, if you need to replace only one module, it will take probably whole of the day because you have to balance all of the voltages of each batteries. In our solution, because we are low voltage and from single battery pack we are optimized, we can just exchange one of the battery module. This as well, upselling is possible by expandable technology. We're just adding the batteries and it will levelize by themselves up to charging up to 100%. What is very important in that kind of situation, that if you manage in the future to upselling, just leave a little longer batteries, leave a little longer cables, or just install the inverter on the proper high. The system is plug and play. That means we are just connecting. We don't need to make such of settings with the BMS and EMS to connect them, to communicate them with each other. The whole system is supplied by the KSTAR. So if we will plug the batteries with the inverter, it will work simultaneously if we would turn it on. We have 200 DC AC ratio, which is very important in the energy storage solutions. And as well, we have a DC-DC conversion and also DC direct to AC conversion. That means if we have 20 kilowatts of PV modules installed on the 10 kilowatts of inverter, we can use the whole power. I will mention it also at the next slides. The EPS functions are built in, so we don't need another device, which will help us to avoid the power outages. VPP enabled, our protocol is well known for many VPP providers, so this is a good option for the companies which would like to be flexible. And also safe and long life solution. We are providing 10 years of the warranty. So this is something what we want to introduce to the market with a safe partners. For example, CLTL, with which company we have a joint venture factory from 6 years, and also EV. This system can be configured in three main ways. I think it's fulfilled all of the ways. First is a DC coupling, so it's this ideal solution for the new PV and storage systems. AC coupling, it's for the retrofitting existing systems, and hybrid coupling in the case that we have an existing system, but we want to extend it by the additional PV power, we can do it. Also, we can firstly do the AC coupling, and then after some time, we can add additional PV modules. This is very quite often solution, and also in a hybrid coupling mode, in the moments when only the PV connected to the inverter is not enough, we can charge from the AC coupling as well. So we can charge from the both of the sides, from the DC and AC at the same time without any problems. As we know, we have a different solution and different households. The new generation improved by the backup output. And right now we are providing 26 amperes per one phase in 3-phase models at the backup output, which is 6 kilowatts. But sometimes we need more. And in that situation, we can connect our devices up to 4 in parallel. The 4 in parallel not only will work at on-grid system, but also will be able to work as an on and off-grid system by connecting to the same power line, the off-grid, the backup, and also the on-grid. At the standalone, we also are providing SG-ready heat pump, and as well in parallel, but because this function is connected by just to the master. So SG-ready heat pump I will mention about it later. And DG auto control is to control the diesel generator in case of really long power outages. In parallel, as I said, we can connect up to 4 units and expand as it required with a full backup output. So that means if we have a 10 kilowatts backup output for one inverter, we can work with 40 kilowatts output with 4 inverters, which I think is very enough for the most of the households. Regarding the flexible works mode, we are providing mainly the self-consumption. This is for the main use, that if the PV is enough to cover the loads, we are covering the loads. If we have too much PV, we can charge the battery, but also we can combine this working modes with the battery priority by selecting different percentage, the different SOC levels of the on-grid system on the on-grid time and off-grid time. That means we can make it little flexible and also peak shaving. It's something that sometimes will be used by the customers, but it's not so important in the residential. Time of use is mostly used by the third-party controllers, but also we can set up some times of charge and discharge in self-consumption mode. So at the general, why to choose BlueSpark? It's not mentioned, but I would like to mention and say it from my side. Everything is from KSTAR. So the BMS is from KSTAR, the battery is from KSTAR, and the inverter is from KSTAR. The whole R&D is working for us. So in case of the problems with the batteries or with the inverters, we can act fastly. If you have some kind of warranty issue, you can contact only us. This is very important. If our competitors are using different inverters and the different batteries, sometimes the warranty issue can be, let's say, it can be complex situation because some kind of problems reported from the inverter can happen from the batteries and also in the different direction. So the performance is a 200% DC-AC ratio, the SG-ready heat pump, the DG mode, and unbalanced output. I didn't mention it about it, but I will in the next slides. The safety, the tier 1 battery cells, giving us a trustness and opportunity to working worldwide. Until now, after thousands of the installation, we still don't have any safety issue. AFCI is an optional, but it can be provided to you. Just ask our sales, Lisa, for this information. We met EU battery regulation, intelligent early warnings, like our BMS, for example. If we'll connect plus and minus and we would like to make the short circuit, all of the batteries contains the BMS, and if the battery will detect the short circuit, it will just disconnect, and that's all. So there will be no risky situation. But for example, if you are stacking the high voltage solutions without the BMS on the module level, it can be risky because there is no BMS, there is no safety devices. The simplicity is battery ready for the upselling, the easy installation, wireless commissioning, and smart AGMS. Regarding 200% DC-AC ratio, that's what I mentioned about. We have two converters. So, for example, if we will connect to the standard PV string inverters or other brand hybrid inverters, it can be cut at the maximum nominal level of the power of the inverter. In the case of the KSTAR, if we are considering the high maximum power, we can charge the battery from the excess of the energy, and the rest we can supply the loads or send to the grid operator. SG ready is a configurable. We have a day mode and the night mode. it activates when the powers of the excess is threshold. So if we export to the grid too much, we can decide to use that kind of energy in case of, for example, during the day or along the day, the price of the electricity is relatively low. So this time we can just use this energy to higher the temperature in the boiler, for example. It don't have to be the heat pump. It can be a heating coils or something else that use the energy. We can also send a signal, for example, to some kind of external controller. And if the external controller will see that there is a signal for increasing the demand of the electricity needs, it can, for example, turn on the air conditioner during the summer. So in the night mode, we will turn on if the SOC will be higher than the set value and there is no condition regarding the threshold. The backup power we can combine with the diesel generator. Of course, we need the external ATS, which will be compatible with the diesel generator because we don't have the input of the diesel generator inside our inverter, but we can do the communication with the dry normal closed or dry normal open contact. So we can work with this diesel generator, and in the diesel generator mode, we will describe two SOC levels, the DG level on and DG SOC level on and DG SOC level off. Of course, both of these conditions will work only at the off-grid time. So in case that we have power outages and we are using our batteries and we started from 80% of the DOD of the SOC and we go to 30%, then we decided to turn on the DG, and if we will reach 50%, for example, we are turning off the DG. Regarding the unbalanced three-phase output, some of the countries require, for example, if you will receive the connection papers from the DSO that you cannot export anything to the grid, you have to be compliant with it on a single phase level. For example, that country is Czech Republic. And some of the countries can change this law in the future, so it is better to be prepared in advance. Regarding the output, we can export maximum 6 kilowatts per single phase, which is 26 amperes, and the rest we can export, for example, the 0, 1, or 3 kilowatts. It's okay. And what I mentioned, we are working with tier 1 battery cells producers. It's top 2 because we are dealing with the CATL and also the EV energy. But what is very important that we have our production line with the CATL, which is in 80% belongs to KSTAR. Regarding the AFCI, many of customers were asking about it on the European market. So we implemented it. It's an optional function, so it's important to confirm before the order if your devices will have it. It just can be checked by the product number. So it's without any problems, we can be sure that our products will have it. Some kind of insurance company are requiring, and if we want to buy the insurance for our energy storage system connected with the PV modules, they can ask if the inverter contains AFCI. And if it contains AFCI, the payment, the fee for the insurance will be lower. Battery ready, I mentioned about it. It's mostly for the upselling. We know that sometimes clients want to just only install the inverters because the batteries is an additional cost, so sometimes they don't want to deal with that additional cost. They want to install the inverter. But if you can use, it's better to install the inverter, which is hybrid, because After 1 year, you can call to the customer and say, you see how much you are selling to the grid at the low price of the electricity? Yeah, buy the batteries. And he will say, yeah, sure, add the batteries, and we are compatible with it. Installation, plug and play. In the old versions, you had to buy the batteries, inverter, and the cables. And then we had to connect the cables with the inverters. And from my experience, sometimes it was a problematic for the installers. With the new version, there is not such a problem because we are stacking battery on battery and then inverter. And on the next slide, I think on the next slide, I will provide you and show you how looks like the installation process. And on the last slides, I will show you a little screenshots from the SolarMan application, how to commission that kind of system and how to set it up. First of all, also I would like to mention that also this is very easy for the distribution because you don't need to prepare, you don't need to think in advance what type of the systems you will use, like with the 2 batteries, 3 batteries, 4 batteries, 6 or 8. Then you can only think if you will use up to 4 batteries or more than 4 batteries, because to the 4 batteries, you are ordering just the batteries and the inverter. That's all. No wires, no communication wires, no additional BMS, no EPS box, nothing else. Just the battery and the inverter, because the floor stand is tightened up with the inverter in the standard. So you receive the inverter, floor stand, and the batteries, and it's enough. For the solution with 5, 6, or 8, 7, and 8 batteries, you will need the floor stand additional, which will connect 2 stacks of the batteries. Regarding the regarding the installation process, we will go through it. I will go forward. So this solution is like 3 batteries, so it's 15 kVh and 1 inverter. On the video it is a single phase inverter, but it doesn't matter, the solution is the same. We have a DC inputs on the left and AC outputs in the communication interfaces on the right. On the bottom of the inverter we have a male connection, and on each battery we have BMS. That's why we can turn on the batteries one by one, or we can turn on the batteries from the inverter. Both of ways are similar and equal. What is showing to us that each battery contains the BMS. So if we have a problem with any one of the battery, we will deal with it from the module level. The whole configuration during the installation is making by the Bluetooth application of the SolarMan. And I think maybe for some kind of reason we would like to prefer the LCD screen, but it's really convenient, and I will show you why. As you can see, we are providing the inverter, and the inverter is tightened up with the floor stand. And this floor stand we will use for putting on the batteries. Then we are connecting, tightening up with the mounting brackets, and then tightening up with the wall. And maybe I will go further with this case, because then we will install on the movie all of the batteries. As you can see, the batteries are stackable, so the male interface from the upper battery is going to the female interface in the lower battery, and we are dealing up to 4 batteries. Then we are installing the inverter in the same way. Okay, the last part is the installation of the inverter. So as you can see, it's very easy. There are no wires, there are no communication wires. Everything is automatical, just plug and play. If we will fix everything to the wall, we can proceed with the connection of the wiring, like the PV modules and the communication, the grid and EPS connection, and so on. We can use 4 square millimeters or 6 square millimeters. Is depend on your personal installations requirements. And we have 2 MPPT inputs, high amperage. And what is important, we have 2 inputs, 1 input and 1 output. The input is for the grid, is an input-output terminal. The backup is only output terminal, so be aware, just do not miss it. Do not connect the grid into the backup. The system will not work properly. And also, if we are connecting the parallel solution, it's very important to keep the same outputs. I mean, all of the backup outputs to the backup power line, and all of the grid outputs to the grid power line. And also be aware that before each inverter, in case of any maintenance service, everything, there should be installed the AC circuit breaker. I think it's quite standard solution, but also it's better to mention about it. Then everything what we need to do, and what is the most important, is the connection of the current transformer. Let's say the current transformer or the smart meter is like the eyes for us. It will tell us to the energy storage system how to see the power energy flow, to charge or discharge, and how much did it should to supply the electricity, how much electricity did it needs to supply to the grid. Also, it is important that if you will face with some kind of problems regarding the connection, the current transformer, the measurement will be not so good and accurate. We can calibrate the current transformer, and the inverter will detect which phase is installed on which current transformer. This is something that makes our installation life, say, easier. Regarding the monitoring system, we at the moment are providing the third-party solution, which is SolarMan. We also are working, and in the first quarter of the next year, we should issue the new system, which is KSTAR Sync. It will allow us, for example, for dynamic prices dealing with. But also, we are providing the third-party solutions for the home appliances, which, for example, can connect all of the devices in the building as a smart home and control it through the third-party solutions. But for the, let's say, for the exact names, it's better to check on the local market. Regarding the configuration process, we have some sections which we are going through. I just highlighted the most important settings. So let's say avoid about the rest. If you want to make it clear and easy and everything is working without any special requirements, we can deal with those settings. So the first is to set up the battery settings, like the on-grid discharge depth, the off-grid discharge depth. We can set up the battery discharge power or battery charge power. It's not important. I mean, this is, for example, if we have some kind of limitation, or if we want to work with the 0.25 C ratio, for example, for the longer life of the cycles, we can do it, but it's not so important. The most important is on-grid discharge depth and off-grid discharge depth. The on-grid discharge depth telling us how many percentage of the battery we want to use during the on-grid mode for the self-consumption or peak shaving. The on-grid DOD telling us how many percentage maximum we want to discharge the battery for the off-grid, for the backup solution. So if we have here like 20 and 90, that means the 20%, we will go from 100% to 80% in the on-grid time. And if we will discharge up to 80%, we will not discharge it further. Then we will wait for the power outage. And if the power outage will come, we will discharge it up to 10% of the DoD. And then the second case is the battery self-check. We can enable it. Is a battery self-check calibration after some days. The system will just check if the batteries were charged up to 100%, which is calibration point, or it was not. If it was not charged, for example, for 14 days or 20 days, the system will charge from the grid to perform the battery calibration. And the last is the read and write button. We can read the values fastly and then we can set it up. Then we are setting up the grid code. There are different grid codes for the whole of the Europe. I think you are familiar with it. And then we can set up the scene settings. The scene settings are what is the working mode of the inverter. I choose the self-consumption because it's the most common in use solution and working mode. We can export the power output of the inverter to the grid. We can limit the export to the grid. We can set up the self-consumption charge enable and when do we want to charge the batteries. For example, if we have two tariffs and one is much more cheaper than the second one, we can charge during the winter from the low price tariff and use it at a high price tariff. And the second is a demand control enable. So if you have limited connection with the grid, we can set up the demand control enable and set up the demand control power. That means if we will, for example, charge the batteries from the grid, and we have actually the heat pump, for example, is working, and the connection power is like 6 kilowatts. Heat pump is taking 2 kilowatts. Our inverter will not charge more than 4 kilowatts to ensure that the grid switch will not trip. And then we have a setting for the battery ready mode if we want to use it. Some kind of advanced functions. If we have third-party controller, we can use remote enable. If it's in standard disable. Also, the temperature control of the heating film. If we have an AC coupling solution, the PV start voltage. If we are using current transformer or meters. If we are dealing with the parallel installation. And what is a grid type? Mixed mode means the balanced output, and independent mode means unbalanced output. And I think it's the pre-last settings for the heat pump. We can set up the grid power threshold. So how many electricity we will push into the grid, and then we will turn on the contractor, and also SOC control start time and end time. For example, if we will see that at the morning from 2 a.m., for example, to 4 a.m., we still have 80% of the batteries. We can force the heat pump to discharge it to use this energy before we will charge from the grid, from the PV modules, because the sun will rise up. And the last one is the settings for the diesel generator. We have this off SOC and on SOC. On SOC always need to be lower than off SOC. We can choose also the dry generator enable and dry generator power just to avoid the overload. And from the commissioning side, from the setting side, and about the products, it was all from my perspective.